Hi, welcome to week 8 of our computer graphics series. So today what we're going to be talking about is L systems. So L systems are essentially it's a type of formal grammar where we use repeating patterns to draw much more complicated things. Now, when it comes to like the applications and where L systems are used, they're mainly used by a lot of programs to actually, draw realistic natural objects like trees, skyscrapers, landscapes, and stuff like that. So an example of a L system. Let's start with something simple. So let's look at this. This is called a coach snowflake. So I'll just show you what one. So this is the base image that is there. Now, what the grammar does is that it takes each line in this image and essentially replaces each line with the same overall picture for each iteration. So this is just one iteration. Second, I make it two. You'll see that every single line that is there in this has been replaced by the same thing. And as you increase the iterations, you get more complex, more natural looking things. So this could be something like a flower or something along those lines. If you increase the number of iterations, uh, you can get very beautiful looking things. Similarly, it's used for building trees in games. So this is the base that is chosen. And what happens is that at every single point, depending on the stack and depending on the rule that you give it, it kind of repeats that same pattern and builds something more interesting. So this is my first iteration. My second iteration is this. So you can see that that same pattern is repeated at each of the steps. And as you increase the number of iterations, you can see a more tree-like picture starting to appear. So that's the basic idea behind L systems. And I'll quickly jump into some code, which actually has an animation of what exactly happens when you know, build an L system or want to visualize an L system. So it's a simple module written in Python using tkinter and turtle, and essentially it's just telling the turtle where to move and how much to move based on the grammar that we are giving it. So let me just quickly run the. So for any L system, we begin with the alphabets that are being used. So let's go with A, B, plus, and minus. Okay. And the thing that we have to realize here is that because this is a program that's written in Python, we have some liberties which the online tool that I just showed you does not have. So I'll just get into that a little bit, I'll get into that soon. So replacement rules for A, I'm going to say A becomes B minus A minus B. And what is interpreted when an A is encountered is the turtle moves forward for 10 steps. Okay. And similarly for B, I'm going to make it B plus A plus B plus A. 1 second, sorry. And again for B, it's a forward movement of 10. I'm going to make it start from the north so that it goes up and doesn't move out of the screen. Plus gets replaced by plus, minus gets replaced by minus. And here for the plus symbols, we're going to say that the turtle moves left 60 degrees and move right for 60 degrees. Okay. When I click generate, you'll get an animation of what exactly is happening. And after the grammar has been decided by the computer, that's when the logo, the turtle starts. So it moves forward, then right 60 degrees, then right 60 degrees, left 60 degrees forward, and so on. So you can see that this pattern is basically what gets formed. And that's the basics of L systems. If I can increase my iterations here, same as before, and you'll see the image becoming more complex and more um, detailed, and so on. Okay, here it moves out of the screen. I'm sorry, but yeah, and that's about it. When it comes to this particular program, because it's written in Python and uses Turtle, there are a few interesting things that we can do now. So the first, one of the most interesting things is we can use the random function. So Random dot choice. So essentially, I can tell the turtle to choose a random value to rotate to after every iteration. So as I was saying, we can put these random values, and the curve that's generated through that is actually really cool. So I'll just show you a demo of that. So here you can see it's kind of building like this honeycomb structure completely randomly. Again, it went out of the screen, but yeah. And so this is really fun. And let me just change the starting location to say -100. Should probably give us a better. Yep. So here the algorithm completely randomly chooses whether it has to turn left or right. And since the angles are exactly 60 degrees, there's no overlapping or like a scribbling motion, and it's able to draw these cool little honeycomb style uh, things. So yeah, that's L systems. Thanks for watching. Bye bye.